And we're back.
And we are back. Welcome back. I'm Christopher Harrison. That's Susan Ibach. This is building websites with Python and Django. And I'm going to be slightly unprofessional here. Barry, do you want to reset the timer for me, please?
Oh. Otherwise, I'm just going to talk on and on and on. And all those poor people who are, it's already 6 p.m.
Yep.
will be there till 4 a.m. You guys want us to have that timer.
Yeah.
You do.
Yes, much happier. Thank you, Barry. Okay, in any event, just in case Barry decides he later wants to clip that out, this is building websites with Python and Django. That's Susan Ibach. I'm Christopher Harrison. So there's been a lot of questions in the discussion about, can you compare Django to fill in the blank? So can you compare it to PHP? Can you compare it to Ruby? Can you compare it to MVC? Can you compare it to a lot of other different platforms?
ASP.NET.
ASP.NET. And here's the thing is, at the end of the day, all of these are different tools, and they all have different strengths and different weaknesses. So for example, when it comes to, let's take, for example, Django versus MVC, and I'm going to focus in on two real quick things on each of them. First of all, let's talk a little bit about forms. That one very cool thing that Django offers is the ability to actually create a class that's going to represent an HTML form. And so all I have to do is essentially create a placeholder, say, hey, use that class, and Django will automatically create the HTML for that form, which can be very powerful.
But on the flip side of that, if you're one of those people who's very picky about the way you want your form to appear, you may not like the way the default form gets created. I actually saw a couple of comments of people saying they found getting the form to look exactly the way they wanted to they found a little frustrating with Django.
Absolutely, absolutely. And so that's it. So with MVC, I don't get that automation. And MVC, at least out of the box, and I know that
MVC, do you mean ASP.NET MVC?
Yes.
Okay.
ASP.NET MVC. And I know that there's going to be somebody in the forum that's going to say, well, wait a minute. With MVC, I could write code that would do this and automatically generate a form and so forth. And you're absolutely right. And I've actually written a lot of that code myself. But here's the thing: is that that's something that's not out of the box. That's built right in with Django. And so that is one of those advantages, that it's very easy for me to do that in Django. With MVC, it does require that I go in and start creating that little bit of a framework on my own. So, it's kind of a, which do you like? Do you like that level of control, or do you just want to use what's out of the box? Or to go with one other thing, with routing, MVC uses what's known as attribute routing.
Again, I can say ASP.NET MVC.
Yes.
Just because we've been just talking about MVC and Django is
sure.
So I just want to make sure we're really clear there.
Yeah, ASP.NET MVC. So the thing about ASP.NET MVC is it uses attribute-based routing, which means that I go to the controller and then I decorate the controller and I decorate the different actions inside the controller with different attributes. And so all of my routing is actually handled on the controller. Meanwhile, with Django, it's all done by using regular expressions, and it's all done inside of the little URLs py file. Of course, you can create multiple, but it's done inside of there. So it's sort of a different approach. And so, which do you like? Do you like it on the controller, or do you like it all centralized? And so Django is going to give you all of that centralized. With MVC, it's going to be done on the controller. Now, one last little thing, and then I'm going to let you take the rest of the module, Susan, is once again, with MVC, I know that you can also do your routing centralized as well, but the preferred mechanism now with MVC is to do that inside the controller. So all of that's a very long, kind of rambling, I think, way of saying is that each one of these will have its own strengths, its own weaknesses, its own little quirks, and a lot of times it will come down to a matter of personal preference, and sometimes it will just come down to a matter of, you know what, and let's go back to the forms thing. I know that Django can create forms. I just need something up right now. Django's going to be perfect for that because it will automatically create the forms. I don't care about formatting. Go. And so you could just do it with Django, for example. So it really just comes down to a matter of personal preference, and each one has its own advantages and disadvantages. You want to talk about ORM, don't you? You just want to talk.
I'm going to have the easiest MVA ever. What I was going to say is, to sum up, it comes back to the answer you can put to every single question that ever comes back to the Q&A. It depends.
Yes, it depends.
Unfortunately, that is the answer. It really depends what you're trying to do. So the strengths of Python Django, it can create forms for you very quickly with a preset layout.
Yeah.
So that's, some people like that. Some people aren't happy with the preset layout, so they might prefer something else. But that's one of its advantages, is that for quickly building a website that is going to give you forms to show you and access a database, Django, that's one of Django's advantages.
Yep.
All right, now I think it's time to get to a file new project.
Yeah, let's do it.
We've covered a lot of high-level stuff. Let's actually dig into writing some code from scratch. So what I'm going to do is I'm actually going to start talking about that back end of, we keep saying Django's good at talking to a database. Let's start seeing how that works and how the code works to do that. So what I'm going to talk about in this module is I'm going to just sort of talk about the concept of a model. You talked, Christopher, you talked in that first module about model view controller. We're going to focus in on that first piece, the model in the model view controller. And how does that connect to the database itself? Because the model is in our code. How does that work with the database? And then we'll actually see how you literally write the code to create your model, and then how you connect that model to the physical database on the back end. So that's what we're going to cover here. And we're going to do that very much from scratch and start building that record store setup that we were talking about. Though I saw a couple of suggestions, but it should be a hockey app for the next one, just so you know, Christopher. We should do that one during hockey season. No, at this point, you know.
Yeah,
so.
there you go.
And right now it should be soccer or football, I think, based on
Women's World Cup.
Women's World Cup is on.
Go USA.
Go Canada. All right, so when we talk about code and we talk about a model, what exactly is a model? Well, when we talk about model view controller, I'm just going to bring that slide back up, that diagram we had. So model represents our data. The view is how the user is going to see that data, and the controller is what's handling the user's requests. So when a request comes in to add something new to the database, and then to return results back to the user to display something, that's the controller. In the end, this is all code. It's just how we're separating it. We think of the model code, the view code, and the controller code. So again, using that diagram we saw earlier, a request comes in from a user. It gets sent to the controller, where there's some code that says, oh, look at that request coming in. How do I handle that? And that controller might say, oh, they've asked for information about a particular artist. So that point, the controller goes off and goes to the model and says, hey, I need data about this particular artist. And then that data needs to be put into a view to decide, well, how do we show that information to the user? And then that actually gets sent back to the user as a web page that they'll actually be able to see containing the data they requested. So the model, again, that's our data. And the data you want to see depends entirely on the entire sort of application you're building. So it could be customer information. It could be product information. It could be information about hockey players or soccer or football players. It could be reservations for a restaurant. So that's the data that we're really working with inside our application. And in code, the model is a class. So if you've done any object-oriented coding, and if you haven't, this is something you're going to want to just go read up a little bit on basics of classes, properties, and methods, and inheritance. Those are sort of the basic concepts you'll need to be able to work with models inside Python. For us, a model is a class. So basically, for every table we would have in the database, we're going to end up with one class in our Python code. So if I have, in our case, we're going to deal with some artists, different musical artists, and keeping track of the albums they have. So I would probably, in my database, end up with an artist table and an album table. So I'm going to create a class for artist and a class for album. Now, just creating a class doesn't magically connect it to a database. There has to be something we can do that changes it from a class to really being a model that represents our data. So there's a few rules we have to follow when we create our classes in Python if we plan to use them to represent our data. So let me show you a couple of those rules. Because in the end, our web app is going to be a front end for a database. That's probably why we've chosen Django, with it said customer management system, reservation system, trivia application. Now, a lot of times, traditionally, if you took our Flask course, we actually showed you how to write SQL statements to connect and talk to the database. And that's, if you already know how to write SQL statements, it's something very natural. But if you are somebody who started off in code and not with databases, having to learn all that SQL isn't always that natural for you. You may be very comfortable working with object-oriented code. The other problem is then you also have to worry about what we call SQL injection attacks. That's where you have a field where somebody can type in the artist name, and they type artist name equals, and then a name, and then they add and select also the system administrator's name from the system and the server name, please, so that comes back on the results. And create a super user account while you're in there. So we have
Obviously, that's not the exact SQL that they'd type in.
Not quite, no. I'm not going to tell you how to hack my system. So we do have to worry about those SQL injection attacks as well. So if we don't use SQL commands, then we're protected from SQL injection when we use this sort of abstraction. And the other thing is SQL can be specific to different database products. The specific SQL used to connect to Oracle for joins, for example, could be a different query syntax than it would be if you're writing it against SQL Server. So there is some slight differences, even though it's a standard SQL. All the database products have a few little quirks and some specific ones. So the other advantage to not writing straight SQL statements is if you ever change database products, it's going to be less rework for you. So that's where this idea of object relational mapping comes in. So the objects are the classes that we create inside our code. And the object relational mapping, which we call ORM, or sometimes called the object relational mapper, depending on whether you think it is doing an action or as it's a thing, it's basically a layer between our code and the database. And this is something Django gives to us. This is one of the things people like about Django. It's one of its advantages if you like this approach to code. And what the ORM does is it converts our queries, which we just write as code in objects by doing like method calls and so on. So we call a method, and the ORM takes that method call and says, oh, I'll write the SQL for you. And then it gets the results back and puts the results nice and tidily right back into our classes for us. Whereas if I was doing this in something like Python with the Flask framework, I would be writing a SQL statement to say, go to the database, get these results, take the results, put them into the properties represented by the class. So I would do that manually. The ORM is going to do it for me. So if you imagine I have an artist class, which I've created in my code, and I call a method that sends a query and basically tells the ORM, hey, I want to go get a list of all the albums by a particular artist, the ORM converts that into an SQL statement, which then gets sent to the database. The database executes that query, sends back the results in the data, and you can sort of see that in the diagram there. So the results come back from the database, and then that's used to populate the artist object on the other end. So the ORM is the magic in the middle that's going to save me work. So the bonus of this is it's going to simplify creating your application so you can focus on just writing and creating your classes and not worry so much about the lines of code that connect to and query the database. And it also means it is easier to handle a different database down the road without a lot of rewrite. What you'll discover is this isn't something unique to Python and Django. There's other implementations which are ORM as well. The entity framework, a lot of people asked about ASP.NET and ASP.NET MVC. Well, you can use entity framework or link in ASP.NET. Those are examples of ORMs that you can use in ASP.NET. You've got Hibernate, which works with Java, and we've got this one here built into Django. So this isn't a concept unique to Django, but it's the most popular implementation of it in Python. So how do we actually do it? You know, it's one of those ones at some point we want to start playing. Well, we want to create tables. We have for each table in the database, we're going to need one class. And I did say earlier there would be some rules that make those classes map to databases properly. One of them is that each object is actually going to have methods that interact with the database. There's going to be a save method for each class. The save method is what we will call when we need to do an insert or an update of insert a new record or to update an existing record in the database. And delete for, well...
Wait, hold on. Delete.
For delete, exactly. So it's a delete method we use if we want to delete a record. And we have queries, which we can use, and lots of different types of queries. We're actually going to cover queries in a totally separate module just because there's so much on querying. Now, to create the class, the good news, here's the awesome start. Remember we said Django does some stuff for you. You don't have to write the save method. You don't have to write the delete method. You don't have to write the query methods. All that code is written for you. Sweet. I am a lazy programmer. If you've watched some of my other MBAs I've ever done, I am all about being lazy and getting the tool and the system and the frameworks to do the work for me. So the fact that I don't have to write the code for the insert, update, delete, and queries, 2 thumbs up from me. I'm a happy camper. Now, how is this possible, you may ask?
How is this possible?
Great question, Christopher. I'm so glad you asked. Glad you caught your cue there.
See, I am paying attention to you.
I know I can see you're busy answering things in the Q&A window. It's always tough when we're trying to do Q&A live. So do forgive us if we can't answer every question as it comes up. But the way we do that is we have to inherit code that's already written. So if you take a look at the slide here, you can see that when I create the artist class, it inherits from the model class inside the models package. So that model class inside the models package has the logic for save, delete, and the queries. Now, the queries are generally done through something called the objects collection. So whenever we want to do queries, we have this extra property that automatically gets added to our class because we inherit models. And that is the property we'll use for querying data. If you're a little confused, don't panic. We're actually going to do examples of this in the next module. So it'll make a little more sense when we actually do it. Now, of course, if you have database tables, well, you would usually have columns in that database table. So if I have an artist table or an albums table, I might have the title of the album, I might have the year that the album came out, I might have a picture of the album cover for an artist, I might have what year did the band formed, and so on. So these become properties of our class. So for every column we have in the database table, we're going to end up with one property for our class. And if you think about a database table, you'd probably end up needing to specify the data type of that column. Is it integer? Is it string? Is it date? You'd need to specify the size of that column. Can it hold a really big numeric value or a smaller numeric value? Can it handle decimal places? For characters, usually you have to specify the maximum number of characters you can store in that column. And nullability. Is that column allowed to have a null value in it, yes or no? So when you create a table, you have to specify those values. Well, if we're going to create a class that corresponds to a table, we're going to have to specify the same things. And the syntax for doing that, basically, if we take a look, is you give your property name, and the property name is basically going to be your column name. And then you actually say the word models. So the word models never changes because we're using the models package here. And then .type, and type is actually going to change depending on the data type of the column or the parameter property we're specifying. And then we can specify different parameters. This is going to affect other properties of how the column is treated, like whether it's nullable or not, what size is it, and so on. So the data type is going to be controlled by that type, and the parameters are going to determine things like what size is that field, and is it allowed to hold null values. So let's take a look at a couple of specific examples. So if we take a look here, we actually have a column name here called name. So this is actually going to be the name of the column that would be created in the database. And remember I said this word models here. This doesn't change. It's always models dot, because we're saying, oh, it's going to be a character field because a name is going to hold strings. And then we have different parameters we can specify. So we might specify the maximum length. So it can be up to 50 characters long, 80 characters long, 100. We can specify whether or not it's allowed to hold null values, whether or not it's allowed to hold blank values, and a default value if there's none provided for that column. Sometimes you might have a field such as salary, which defaults to 0. So these are all examples of parameters you can specify for this field you're going to have. Now, that's for a string field. What if you need a numeric field? Well, if you take a look at that line of code, name equals models, char field parameters, the only thing that changes when you create an integer field is this little word here, integer field. So instead of it .char field, we now say .integer field, because we're basically telling the models package, hey, this column I'm creating, and it's funny, actually, now that I realize it's called name, I should have obviously updated that slide. So that integer field basically is just saying this column is, or this field is a numeric data type, not a string data type. But you still have parameters you can specify, such as does it allow null values? You can have default values. You won't bother specifying a size because that's determined by whether you pick integer field or positive integer field and so on. So let's do it. I think it's time to go, and I feel the need to go into Visual Studio and do some coding. Because it comes a point, I get twitchy if I haven't been in there for too long. So I'm going to go File, Brand New Project. I like Christopher's point. There comes a point where you just need to see from scratch. I select Python. I'm picking Django Web Project and Database Fun. All right. And I'm going to go ahead and click OK. And once again, we get this option. Christopher was talking about this earlier about I wanted to install into Python. I like using the virtual environments because that gives me more control in case I end up working with elements of my package that may need to work in different versions of Python. So I'm going to leave it at 3.4 is the version of Python we're working with. I'm going to say go ahead and create that. And then I get to play the, what can I do to pass the time while waiting for this? So what I'm going to be doing is when this is done, I'm actually go ahead and start creating classes in the code that are going to represent the database tables. And we're going to have an artists and we're going to have albums because we're working on this record store example. And what I'll need to do is I'll need to create those classes. And of course, there's model, view, and controller. And because I'm working in the models, I'm going to go, when I open up the Solution Explorer, I'm going to be adding this to the models code. So I'm going to create albums, I'm going to create artists, and then I need to think about what would the columns in the database be. And for each column, I'm going to have to go ahead and create a property. And still spinning, and it's a beautiful day in the neighborhood, isn't it? Oh, here we go, we're off, okay.
There you go.
Otherwise, I was going to burst into song. It's amazing. I don't think even Visual Studio wants to hear me sing. Now, if you look at my screen right now, just want to reinforce that it pops up with this thing going, before running this project, you need to synchronize the database.
Don't do it.
No, that's right, don't do it. We're going to show you how to synchronize the database. I'm going to show you actually that in this module. What I want to do, though, is I want to start creating my code. So let's go over here, and underneath the Solution Explorer, under Templates, if you go take a little look over there, you will see there we have Models. So it's under App, under Templates, we're going to go to Models, because remember, we are working with a model. So we're going to add our code to that models.py file. So I open up that file, and you'll notice, the first thing hopefully that you notice, is that it imports right away the models package. That's the one that contains the model class we need to make sure all the classes we inherit have the functionality needed for the ORM to correspond to the database. So now we can go here and we can add a little code.
I love the fact that it just tells you, create your models here. Well, thank you.
Yeah, it's very helpful. I like that. So we're going to create a class called Artist. And this is basically, now the magic happens when we add this line of little bit of a code, where we say this class is going to inherit from the model class in the models package. That's essential. That's what makes the magic happen. That's what gives it the built-in methods that allow it to communicate to the database. And then I say, well, in my database, I would have a name column, so let's add a name property. And how do I declare that? It always starts the same way. Models, dot, and now I have to say what data type is it going to be? Well, this is going to be a character field, so I'm choosing char field. And then I pass in different parameters to specify what's its maximum length, does it allow null values, and so on. And I'm going to specify a max length here of 50. And then maybe I want to ask what was the year formed. And that's models dot positive integer field. I would never have a negative year. So I might say a positive integer field. And actually, I don't really need any parameters. The defaults will be fine for those. Yep. And then maybe I need to create another one for album.
And while you're typing that in the background, we can leave Susan's screen up while she types away here. There's been a couple of questions in the Q&A about people that created the project, tried to launch it, and it's failing, saying it can't find the database. The reason is that we haven't actually created the database, and this was something we kind of mentioned earlier, is that we're not going to be creating the database or even showing the UI until a little bit later. So we are going to get in, we're going to create the database and all of that, but we haven't gotten there. So if you try to launch it right now, there's no database. Django wants that database right up front, and so it's going to fail. So if you're trying to launch the project now, like if Susan tried it, don't do it.
Yeah,
but if Susan tried it, it would actually wind up failing at this point.
Yeah,
so.
I can save it, I can build it, but you're right, I cannot launch it yet. We're gonna, but it will.
Yep, it will.
It will.
Yep.
So I now have two classes, one for artist, one for album. So that's like having two database tables. And in the artist table, if you want to think of it that way, it's got a name and a year formed, because I have fields for both of those. And I have a name field or property on the album class. So I'm defining what effectively is sort of what my database would look like. But I'm doing it with my model. OK, that's it. I bet you thought that was going to be way more complicated code. OK, well, there's some more magic coming. One of the things that comes up all the time when you work with databases is the need for a primary key. Certainly best practice for a table to have a primary key. A lot of the time, the primary key is an ID, you know, album ID, artist ID, employee ID, customer ID. And it's usually an auto-generated number. Every time you add a new customer, it just increases the ID number by 1. Django actually does that for you. If you don't specify an ID property, because I didn't specify an album ID or an artist ID, it'll actually generate an ID column for me and just automatically increment the numbers when I add new records. Awesome. That is just sweet. Now, on the other hand, if you're like, no, I don't want it to work that way, it's OK. You can customize it if you want as well. Let's say you have a string, a character field you want to use as a primary key. Then all you do is when you actually go ahead and create your field, all you do is specify that you specify a parameter of primary key equals true, and now that name field is going to be treated as a primary key. You can do it with integer fields as well. You know, that's fine if you don't want to use that sort of auto number. Or let's say you want to create a field and you don't want it to be called ID, so you have a special column you want to use as your ID, and you do want it to do that automatic numbering for you where it just automatically increments by 1 when it adds new records. You can do that as well. You just specify auto field. And what that does is it creates an automatically incrementing numeric field, and you say, hey, and that also happens to be a great primary key for me. So you get a lot of choices there. I'm going to be as lazy as possible. I told you I'm a lazy coder. I'm just going to let Django generate ID fields for me, automatically increment the numbers for me, saving me time. But there might be situations where you don't have a choice. So you do have control when you need it. OK. Now, the other thing that comes up when you work with database is the idea of relationships, artists and albums. Well, artists record albums. Each album is recorded by an artist. So a lot of times in database tables, we need to keep track of those relationships. So we have the ability to say, give me all the albums by that artist, or go tell me information about the artist who recorded this album. Even though they're stored separately, when I'm presenting information through my views to the users, I want to be able to show the related data. So we have that concept of foreign keys that connect the two tables. And Django also allows us to create foreign keys. And I love the syntax for this. This makes so much sense to me. Because what I do is I create my new column. So there's nothing new there. I create this artist column or artist field. And the first part should look exactly the same. You say it's in models. But here's where it changes. I say, by the way, this is going to be a foreign key. And it's a foreign key that points to the artist class. Now, I don't have to tell it which column to point to or anything. I'm simply saying, hey, you know what? I want to be able to track the artist for this album. And that artist is going to be the artist object. And it's actually Django will take care of mapping that to the ID field or whatever you defined as a primary key in the artist field. You don't have to do that. You simply say, hey, guess what? There's a foreign key here. Album has a column called artist that points to the artist type. Done. Again, this is where Django rocks. It's taking care of it for you. So I guess I should add that incredibly complex code.
Yep, absolutely.
All right, I like to do all the tough demos up front here. They'll blow up later on. So all I do is I go to my album and I add a new column. And this one's going to be called the artist. And it's models dot foreign key. So this is going to be a foreign key. And basically it points to the artist class. Done. I now have a foreign key connecting albums and artists together. One line of code.
And that's it's one of those things that I love about that, is that I don't have to remember what the ID is. And the ID could potentially change. All I have to do is just simply say, hey, there's the parent, and it takes care of it for me.
Yeah.
Yeah.
It's honestly it's the way it should work. I wish it worked that way in most databases.
Yeah.
So it's great.
That table, figure it out.
Yeah, come on. There's only one primary key. You make me point to the primary key anyway, so it's nice. It saves me work. I said, no, I'm a lazy coder. Make Susan happy. Now, one of the things you may have noticed, and if you've done other MVAs or watched any other MVAs with Christopher and I, is there's something very interesting here. If we go back to the code briefly, notice how year formed. Up here, I specified an underscore between year and formed. It's very unusual. We tend these days to sort of go year and then uppercase F formed. The underscores are getting more unusual to use in variable names. That is not an accident. That is not there just because I like using underscores. That has functionality. Christopher mentioned earlier that Django can actually create forms for you based on this model. When you use that underscore, what happens is when it auto-generates the forms, that's going to control the labels that are automatically generated. So year formed will become year space formed. So the underscores indicate that when you generate the label for this, to put a space between those two words. And I believe it puts the uppercase on the second word.
On the first word.
On the first word, yeah. So it'll also do some uppercase automatically. So yes, we do want underscores when you have sort of multiple words. That controls the labels that appear afterwards. So that's something, it's not an accident. It is deliberate. If you want to customize the label, you don't like that. You don't want the name of your property necessarily be the same as what the label that appears on auto-generated forms will be. You can actually specify a parameter, just like we could specify size and whether it's nullable. There's a parameter called verbose name, which allows you to give it custom names. So I can go back to my code here, and what I'll just do is I'm just going to add verbose, actually, I can even just, it's by default, it's actually the first field. So I can literally just specify that for the name of the artist, instead of it showing name on the screen, I want them to know it's the artist name. And I can say album instead of name for the album name, because I think that's going to look better when we actually display a form to show artist and then the name of the artist, album, and then name of the album, as opposed to two fields with the label name on them. That might be confusing to the user. So that's the verbose name property. Another nice little thing you might want to set up. Because if I set it up there, it saves me work later. And so I'm willing to put a little extra work in now if it allows me to be lazy later. Finally, I need to get these. So basically, that was my little demo of getting the model ready for display, controlling the labels that are going to get generated. Now, there's a whole bunch. I've only just touched the tip of the iceberg in terms of types of parameters you can affect that'll change things, how you can handle more complex data types, custom column names, and so on. So there's a link here, and you do have the ability to download these slides where you can go see all the different parameters you can specify when you create the fields that will control the way those fields are created. So lots of options there for you to play with. So we have classes, but I'm sure everybody's still sort of going, how do these classes actually end up as a database?
Yeah, there's been a couple of questions actually around the database.
Yeah, everybody's going, keep going, Susan, because I don't see it.
Yeah.
I'm like, you're still going, the light's not coming on. You're like, that's just too easy.
Yeah, what about the database?
Right, okay, so, all right, let's get on with the database. Okay, first of all, first question, what database is Django going to use? Right, good, excellent question. And the answer is whatever database you tell it to in the settings.py file. So if I go right now over to my Visual Studio and I go find the, where is the settings.py file? I can never remember. Do you remember where it is?
What are you looking for?
Settings.py.
Under database fun.
Under here, thank you, under database fun. There we go, settings.py. And if I take a look here, one of the choices you will see if you dig down, there it is, under databases. You can see it's specifying right now that it's going to use SQLite. Now, I'm going to use that as a default, but you can go and change these to point to whatever database product. If you already have something installed and you want to use that database, then you can specify, your username, your password, host and port, everything here to connect to SQL Server. I saw somebody want to do Postgres. You're just going to have to find the connection string required to connect to that type of database. That's the magic of Django, remember? We can just change the settings here to point to different databases. And I know I'm going to start in SQLite, but you're going to change this later, aren't you, Christopher?
Yes, I am.
Yes.
Yeah, but much later.
Much later, but so we will prove that point. We'll make that happen live. All right, so we're going to be using SQLite inside our my demonstration here, but it certainly works with MySQL, with SQL Server, and other databases as well. It's just the default development database for Django, and it's a nice light one when you're learning and trying things out. It's just a lightweight relational database. It is also open source, so nice place to get started when you're getting into databases. How do we actually create it, though? Because right now, nobody's run a create database command or a create table command or anything. What we do is we do something called migrations. So the way Django ORM, the object relational mapper, works is you say, now I've defined the structure of my database by creating this class. And now I'm going to say, migrate that structure to an actual physical database. So we do this with something called migrations. So there's basically two big steps you have to do. The first here is the command make migrations. What that command is going to do for me is it's going to say create a brand new package based on the code we have in our models, read those classes, read those properties I defined, and based on that, create a package that contains all the changes to send to the database. Once it's created that package, there's a neat little thing you can do. If you know SQL, and it might help you sort of wrap your head around how ORM works, there's another neat command here you can try, and I'll show it to you, called SQL migrate. And what that'll actually do is it'll actually show you the SQL statements that got generated when you created the migration package. So if you have done SQL, doing that might help you understand what's going on behind the scenes. If you've never done SQL before, you just want to trust Django to do its magic, you never have to run that command. Then the next command, this is the magic one, the second magic one is migrate. That's the one that actually says, okay, do it. You created the package, you read my classes, you figured out what the tables should look like based on looking at my classes and the properties that I defined. You created a little package that would create them. When you run the migrate command, you're saying, actually take that package, run it against the database. Which database? The one I specified in my settings.py file, and create the physical database. At that point, you have literally created a database that maps to the models you defined in your code. If later on you discovered you missed a field, or you need to add some additional fields or additional classes, you go back to your model, you add the classes, you change the properties, you add properties, you rerun that make migrations command to create a new package, you rerun the migrate packet command to update the database with those structural changes. Obviously, though, keep in mind there are some changes you might make that might require blowing away all the old data and recreating tables from scratch. So that is something you can't just say, I've decided to get rid of this table altogether, or delete and rename 4 columns. You may lose your data in the database when you try and migrate those types of changes, because I don't know, the database doesn't usually like it when you just rename columns on the fly and change database names and things like that. So there are some migrations that can cause you to have to lose your data to be able to apply the changes. So I guess people, so how do we do it? We start with the make migrations command. The command, in terms of what do I have to worry about, some of this is going to be absolutely fixed. So we call Python manage.py, make migrations. All of that is standard code. That is going to be the same no matter who here is running that line of code. What we need to control is the name we give to the migration. You can leave a default name if you want, but you can give it a name. I'm going to call mine initial because it's the initial migration, creating my database table. But everything else on that slide, everything else you see in that command is exactly the same no matter who's typing it. So all you have to do is decide, what do you want to call your migration? And that's going to read the code in your models.py file and create a migration package. Once you've done that, how do we execute it? In Visual Studio, we're actually going to do it from the command line. So I'll show you how to bring up the command line tool inside Visual Studio so you can execute these commands, because Visual Studio uses an older syntax. So this is the way that's going to work if you're inside Visual Studio. If you end up using a different tool, you may have different ways that you execute these commands. So let's see how it works. So I'm going to just show those models again because I want you thinking more about the models than settings. So there's my classes I created, and there's the properties which I defined. Now I go to my project, and I right-click on the project name, and I choose Open Command Prompt Here. So that's what I'm going and picking, the Open Command Prompt Here. Do that again. And that's going to open up a command window for me. And if we think, what was the command we saw earlier? It was Python manage.py, because I'm running the manage.py code is running this for me. And I'm executing the make a migration package. So make migrations, which will create a package based on my models. So based on these classes I had created over here. And I have to give that migration a name. I'm going to call it initial. And I tell it the name of the application I want to create a package for. My package, or my application, is called app. And that will be your default application name inside Visual Studio. If I'm lucky, I typed it correctly. Woohoo! Okay, score 1 point for no typos there. Yay! And you can see here that it's gone ahead and created a new migration. And this is actually the name of my migration, 0001_initial. That's important to remember, because later when I want to migrate that package to the database, I may want to be able to tell it exactly which migration to move. You also can see it said I found a album and I found artist. So I can see that it's read my models file and found those objects. So the next step, I just want to run a couple of commands to show you a couple of neat things. One of the things you can do is you can say, go to Python. I'm just going to resize this window a bit so that's a little easier to read. Not quite. OK. So Python and manage.py. You always start any of the commands in this command window where you're working with migrations, always start with Python manage.py to specify where the code's running. And I can say, show me the migrations I've created for my app so far. And that will simply give you a list of all the migrations you've created. Because over time, you could imagine, as you're making changes, you might have multiple migrations over time. So that just gives you a list of the migrations you have. And for those of you who do know SQL, I personally, in my head, everything makes more sense for me because I'm really a SQL person. When I do the SQL migrate command, and I say, go look for my app at that package 001 initial, and show me the actual SQL commands you're going to run when I run this command, or when this package is executed to the database. And this will actually come back and shows you the actual create table command. So now I can actually see, oh, look at that. It's saying create table called app album. And it's going to have an ID column. But we didn't specify an ID column.
Nope.
there's that magic of Django saying, oh, you didn't specify an ID column. By default, I'm going to create one for you. It'll be the primary key. It'll auto increment. And here's my name column, which is a varchar 50, which makes sense because I had specified in my model that it was going to be a character field, right? And it was going to be a character field, so that came out as a varchar, and I said max length of 50, so sure enough, it made it a varchar 50. I didn't specify if it was nullable or not. The default is it's not allowed to be null. So you can start seeing how what you specified in your field maps to the SQL statement that's going to be executed against the database. Once you've looked at that, you're comfortable with it, you go, you know, that is actually what I wanted. I'm cool with the auto-incrementing the IDs that it's generated for me. If I wanted to make changes, I could go change the classes, rerun the make migrations to create a brand new package. But I'm happy with this one. So at this point, I'm ready to say, let's do it. Let's put that code, run those commands against the database. So I have a table that maps to this. So I'd run python manage.py. That never changes. And you have two ways of doing the migration. If you really only have the one package, you can just say migrate. And it'll basically apply all current migrations to all current applications. And I only have one app and one migration, so it'll basically run it. Or you can actually say, for my app, I want to run the migration 001 initial. So it's your choice. You can just say, hey, just run the current migrations. Or you can say, for this app, apply this migration. And when you run that, oh, hang on. Let's run. I'm going to do it the other way for now. We'll do it because it's the first one. It tends to be happier if you do it the first way with the straight migration. Python manage.py migrate, and off it goes and says, all right. And if you sort of take a look at the messages and things popping up there, it says, yep, I'm creating your tables. I'm installing the custom SQL, and basically it's just created the tables inside the database. Did you want to add something there, Christopher?
Oh, no, I was going to say the other thing that it's doing is to manage the migrations, it actually has a table that it uses inside the database to track all that. And so it was just going in and also setting that up as well when you call that initial migrate.
Yes.
So that just needs to be done first before you can call those individual migrations.
Yeah. But once you've called that command migrate.sql, I don't now need to rerun the migrate app 001 initial because when it set up the initial tables, it also found that migration and applied it as well.
Yep.
But now any additional migrations I do, I would simply say, only here's the new migration, run this command, or when it's 002 initial, or whatever package names I give it. Every time now I make additional changes to my classes, I would just rerun. I would do the make migrations. So I would run this command to create a new package to reflect the changes I've made to my classes. And then I would rerun this command except I would have to change the migration package name to be the new migration package. And that would migrate changes I made to the class to the database for me. All right. And that takes us to the end of another module. We now have the ability to create classes which define a structure of our database tables, create a package that we can then run on the database to create tables that map to those classes. Beautiful.
So now I guess the next thing would be to actually put data into there and pull it back out.
Yeah.
What do you say we take 10 minutes? We'll come back and do that.
All right. See you soon.
All right. Cheers.